degrees, just because it's going to be so cloudy and so.
What's up, Mr. Casimir?
Some areas could see higher totals, and as we go through the next couple of days, more rain is possible. This purple area where you could see rain more than 6 inches, and some areas you see starting to turn white right here. That's indicating 10 inches. So you could see pockets of 10 inches of rain possible for today, which is not great. That means flash flooding is a high risk for today across Louisiana. Future track radar continuing to have showers and thunderstorms streaming through the area. These bands of rain.
Good morning.
Morning.
Be our proud app.
And then you want to tune in back tonight for Fox 44.
Okay, I'm back. I was on the wrong connection.
Oh, what you mean wrong connection? Oh, you speak or something?
Yeah, yeah. I have a hotspot specifically for attending class.
Oh,
Our
okay,
our
okay.
our our, our internet in the building is a very low bandwidth.
Right, okay. Yeah. Yeah, yeah. I hope more people join. I sent the email out last night because I said it didn't pay for people to come to school and get caught in the rain. You know what I'm saying? Because some people maybe drive 30 minutes, 40 minutes from school. And by the time you come to school, have school, then maybe have to drive home, you can't get home because of flood water. So I just said that we'd rather not have class on campus, but we'll still have class on the Zoom. I hope they didn't show up to school. I sent out the email. I sent a reminder out a while ago too.
Hey, Professor, while
Yeah.
there's just a couple of us, can I ask you a couple questions?
Right, no problem.
Hey, you sent me a message about my program number 2, where I had used the pushback to initialize my values, and I got an email from you. I think you wanted me to change that to using array notation.
No. That was me. You sure?
Yeah, maybe you emailed the wrong student,
Yeah, that could
but
have
it came
been.
to me.
Oh, okay. Yeah,
Yeah,
I
so
might have still.
I didn't know if that's what you preferred, and then I didn't know, like, if you tell me to update a code, or when you make
No,
your comments, if I
that
can
wasn't
send it
yours.
back to you somehow once I fix
Yours was
it.
all right. That wasn't
Oh,
yours.
okay.
What happened was, I think one student, what they did, either they didn't use vectors at all, or they tried to use it in the pushback. They didn't use the pushback right or something, right? But when I
Okay.
looked, I remember looking at yours. If I'm not, let me pull it up and
Yeah,
see.
well,
Cause
you gave me the maximum points,
right, see, so
but
yeah, yours
I
was
thought I had
straight.
to refactor it,
No, it was straight. Cause remember, I told students with vectors, if you uh if you leave it null, you have to use the pushback to add to it. You use the pop back to take away, but we didn't use the pop back. But if you allocate the space for it, then you just use it as like you use array, using an index.
Oh, okay. That might have been it, because I did give the space for it,
Right.
but I still used pushback.
Huh?
But I still used the pushback. I was learning it. At that time, I was kind of new to vectors.
Well, wait a minute. Let me see something.
See, I used the constant for the number of transactions, but when I initialized it, I still did it with the pushback. So I used the constant for the loop, but in the loop, I did a pushback. It still worked.
Yeah. Let me see. Let me go to your program and I'll pull it up. It might have been, yeah. Let's see. Okay. All right, let's see. 2. Okay, speaking. It was this one. Yeah. And where's I don't see a comment in it.
No, I got it by email somehow.
I don't know if
I got a comment by email that said, paste this code into your program. And when I looked at it, the only difference with my code was that I did not use the array subscript to initialize. I used the pushback to initialize.
Unless I was answering a question early on, I don't see it. I don't understand. Let me-
Okay, so that's fine. Look, I have another question for you about our program due this week,
Right.
program 6.
All right.
So, sir, we had last week 3 and 4, and 4 was done with vectors.
All right.
And
It was
a different sorting. It was a different sorting and a different searching in 4.
All right.
So for program 6, are we doing it to replace number 4 with selection sorting and binary search?
Any one you want, but both of them gonna have to be arrays.
Okay, so we can do the same program twice this week, but
Right, but you're gonna have to manipulate it different, right?
Yes, sir.
Because remember, in one instance, you're gonna manipulate the array by using the plus, and it moves to each different address, right?
Yes, sir.
It's gonna point to each different address. Then you're gonna use the one by using the dereference and then adding 1 to the array, which would actually move it over, right?
Okay, so
you're not changing the program itself. All you're doing is changing your loop for your output.
Just the output?
Right, because you're not really writing now, remember I told you it was bonus if you do pointers
Everything?
for all the other stuff.
Okay.
But the program itself, all you're doing is changing your output function to manipulate it using the plus and the dereference plus, the subscript.
Okay, so I could take the same program and do
correct.
2 different ones of the same.
Right, because I never specified. What I told you, just in reference to this program, do whatever. Right.
Okay,
right.
you know that I've been making mistakes with my specifications. That's why.
Right, I understand. Right, and like I said, once we get it clear, then you can go into it and know you're doing it the right way. Right, I understand that, and get your maximum points. Yeah, and nothing wrong with that. Okay. All right, so let me see how many people done logged in. They might have them on campus. Let's see. Where's my Zoom? Where's my Zoom?
There's 11 of us, I think.
Okay, all right, that's good. I'm trying to find my okay, here we go. All right, yeah, okay. We got Miss Thomas, I got Sanders Morris, Miranda, okay, Boudreaux, all right, Padron, Pardon, Deja, Williams, Cavalier. All right, Booker. What's up, Mr. Booker?
How you doing?
All right. What was your last class period?
Remember I told you I was out of town.
Yeah, that's right. You sure did. Cause I called your name in class. I said, "Where's Mr. Booker?" Cause I said he wanted me to go over one of those processes of the code for searching or sorting one of them. Now, before we start with class, anybody got any questions, concerns, whatever, however, like I say, assignment dates or whatever? Because with my other class, I kind of been lenient, and I kind of push dates back if students, had issues trying to, like I say, get it done. My phone, I forgot. Based on, like I say, the weather, etc., having to deal with whatever. So anybody with any concerns, questions, a test, whatever, didn't take it, need to take it or whatever. Well, that's on anybody.
Yeah, I actually need to take, I think it's the chapter 9 test. I missed that because I had work and then a bunch of other stuff in a day, and I literally just couldn't get the time.
Okay, chapter 9. SO1, okay. Was that one available for this week?
Chapter 9 is due at the end of this week,
I
right?
meant chapter 8, I'm sorry. Or
All
chapter
right,
9.
okay, yeah, all right, okay. So yeah, I could set that. And then anybody have any other concerns before we get started? Because like I said, I know I got emails, hey, Mr. Sylvester, my lights out, hey, Mr. Sylvester, displaced and all that. So I want to try to make it, to where, you're not so stressful. You got your time, get a little time to do whatever you have to do, so you can
I need
make
to
it better.
finish chapter 4 program.
All right, chapter 4. All right. Now chapter 4 program, that code, I don't know if you was in class, that code, you got to make sure when you copy that code, you have to match it to what your variable name is. Now, not all the variables, because some variables are just being introduced in those functions, correct? But the ones that you passing, you have to make sure you're using them in the right place for your to work, for your program to work. And also, if you're doing your sort, remember we talked about if you move the year to if you're swapping the year, you have to swap the name. The name and the amount also, right? So those are some of the things you got to keep in mind when you're doing a program or those programs. All right. So what I'm gonna do? As test 2, right? For Mr. Sanders.
I meant the quiz for chapter 9, not the test. I'm sorry.
Okay. So the quiz. All right. Let me edit it, and I'll just make it due for a Sunday. Give you enough time if you're working, whatever, you'll still be straight. And I'll just make it for Sunday for everybody. So anybody who miss it, and Sunday would be the 19th. Okay. Okay. And now, that was Miss Williams, or who was that? Hello?
Yes, that was me.
That's Miss Williams. What assignment you said? 4?
Chapter 4 program.
Wait. Chapter 8 program? Wait, chapter
I'm in program 4. I didn't mean to say chapter 4.
okay, all right, program 4. So what I'll do, and I could open up 3 and 4, 3 and 4, 3 and 4, 3 and 4. Yeah, I'll open up 3 and 4 and till Sunday. So, but I still gotta grade them. So yeah. So I'll open them up until Sunday so that hopefully you can go back, look at them. I always grade the latest submission. All right. So, but like I say, get them done now, because I will grade them. And then I'll share my screen. But I want you all, hey class, while I'm doing this, it's gonna take me about 3 minutes. I want you to go under announcements and pull up this code. This it should be the very top announcement, and I think it say fix this code. I want you to fix that code. Don't add nothing else to the program or whatever. Just fix it so it'll run. Now the program is partially done, but it should allow the program, once you can fix it, it should allow you to input the 8 different quantities and cost in the program. It shouldn't allow you to calculate anything, but it should allow you to input the quantity and cost. I want you to go over that program, copy it and paste it into your C++ compiler and fix the error. All right, and do that right now while I do this. I should be finishing a little while.
Professor Sylvester, that's the email I was talking about.
Oh, that's the email you're talking about? Yeah.
Yeah,
Well,
I wanted that
for a class assignment.
Okay. Okay.
Yeah. Oh, you done it?
Not yet, because I wasn't sure what was going on.
Right. It was an announcement. I want everybody to just do that. Try to see if they could find what the problem is in that program.
Okay, and then what do you want us to do? Send it to you?
We in class, so once you get it, we'll talk about it.
I'll do it right now.
Right. Because when I start grading programs, I look at programs and if it's a small error, I try to find it. And it took me a little time. I had to do some things to focus on where the problem actually was. And it's a very simple fix, but it's just that, man, sometimes when you're writing code, you got to be very cautious of what you do. All right, so try that. And like I said, I'm gonna finish these last two, and then we'll look at it. Okay. And what I'll do, I'll show you what it does. If you don't get I'm gonna show you what's the problem, and I'm gonna show you what it does in your program to cause it to give an error. This is the last one. All right, so now let me share my screen. I'll copy that code too.
Okay, I found a little syntax error right off the bat.
All right. Well, but it wasn't a syntax error because you didn't get an error on it, right?
Well, I didn't run it. I just looked at it in my online GDB. I didn't run it yet, but I saw a comma that should have been 2 arrows.
All right. Well, that's one.
Okay, let me keep checking.
Right, but change that and run it. But don't give the answer next time. Yeah. Okay, so I'm gonna share my screen. If I could find my my tab. Okay, here we go. I'm gonna share my screen. And so everybody can see my screen, correct?
Yes, sir.
Okay. All right. So let me maximize it. Okay, so this is the program. All right, and what Mr. Man.
Yeah,
Mr.
line 18, that comma.
Right, Mr. Kamal. Yeah, that's it here. Yeah. So what happened? This was an error. It had a comma here, but there's another problem with this program, and I ran it. I said, wait, let me do this. Then I printed out, because it kept telling me what kind of error you get. It says the subscript of the vector is out of bounds, correct?
Yes.
Right, correct. So what's happening here, for whatever reason, in this function, when they get here, they setting this at 0. Well, it's saying index is equal to 0. But for whatever reason, when you get here, index is 9. Everybody with me? Now you say, well, how you know it's 9, Mr.
That last sentence?
Huh?
Can you repeat that last sentence?
All right. What
You
happens
said when we get to index plus 1?
No, that's not the problem.
Oh.
What happens is we have index here. We say for index is equal to 0. Index equals 0, right? This is our for statement. Then when we get into our loop, index is 9. And how is it 9? And we'll look at it. So I'll do a C out. I'll do index value, and I'll do index. And what I did when I ran it, I'll go in there and run it. All right, so see what happened? It says that the index, what? Vector out of subscript out of range. Because what? Our subscript should be what? 0 to 7, correct?
Yes.
Because 0 to 7 is 8. Right? Now, so how is it that we setting it to 0, but once we get down in the function, it's at 9. I mean, it's at 8. Well,
You're adding one to the.
Huh?
Should I be saying this out loud?
Yeah, go ahead on and say what the problem is.
Well, when index is referenced below in the cout statement, first of all, in both cout statements, you have index +1, which makes it go from 8 to 9. Well, I'm sorry, 7 to 8. It's 0 to 7. Which is why you're getting that, and it's referenced in 2 places. So it's referenced on line 19 and 23.
All right, so let's do this then. Let me do this. Semicolon, well, inline and a semicolon, and I'll do // as commented, right? And where you say here to, so I'll do // So now I've just commented out those things you talked about, correct?
Yeah, but there was never an index equal, so that's not going to change the value of index itself.
Right, but I'm just trying to ask if, see, we kind of learn it. So, but you're right. That's what I'm saying. So let's look at it. You're right. Watch. I'm gonna get the same value out of bounds. See, and the value is still whatever, regardless if I comment them +1 out. Right. Now, anybody got any idea why we have an issue with this program?
It's the semicolon on the for loop.
Yeah.
That's the problem. And man, that can run you ragged. The only problem with this is this semicolon at the end of this statement. And if you writing code and you got hundreds of lines of code and you just looking at it, you can overlook that. You know what I'm saying? You could overlook that. And let me tell you why, what this semicolon does. With that semicolon at the end of this for loop, it will run only this line until it's satisfied. So what? Index 0, index less than 8, right? It's gonna add 1. But it's not gonna leave this line because what? I put a semicolon now. So it's gotta process that line until it completes, until index get to until index is not less than num items. Everybody understand that? So it's gonna process that line. So index gonna keep incrementing till it gets to 8, because 8 is not less than item num, 8 is equal. So when we get down here, index is 8. And when we try to add CN quantity sub index, we trying to input quantity into an index that's out of the boundary of the vector. Everybody got my point? Hello?
Yeah.
Yes, sir.
Yeah.
All right, so now watch what Huh?
We'll know when we see that.
Right, and that's what I'm saying. Make sure, because man, you could be running, it can drive you crazy. You're like, man, I know my logic is right. Man, I know I got it right. Man, I know everything is in order. But what you're doing, you're reading this and you're like, oh, this is good. And you're not even looking at the very end. And then you're saying, well, my if logic is good, what's going on? So watch when I run it now. You understand? Well, remember I took those plus ones off, so that's why I did this. So, but you understand, man, any little thing can cause your program to, like I say, not run, all right? Cause you big issues. Right, Mr. Booker?
Yes, sir.
All right. Okay. So, I didn't want you to keep that in mind, class, because like I said, if you can practice knowing that, okay, this loop, any for loop, while loops, depending on how you do while, depending on how you do it, you should know where the semicolon go. But this for loop, unless you just want this to run and increment without anything done, you don't put that semicolon here because you're saying this is not a part of the for loop, right? Once you put the semicolon here, you says this is not a part of the for loop. Just execute this one time and continue. All right. Everybody got that? Okay.
Got it.
All right. So now let's go to our notes. We were talking about pointers. All right. Now let's look at the assignment, and then we'll get into our notes, because I want you to see what I want you to do. So when we start talking about it, you'll be able to ask questions rather than you seeing something and then all of a sudden I'll give you the assignment and it's like, oh, well, we went over it, but I could have had questions and I don't know what to ask now. So let's look at the assignment and see what it is the assignments entail. All right, move this bar out the way. All right, so in the assignment, all right, the assignments, make this a little larger for you all. All right, so in the assignments, assignment 5. Now, again, if you did not do the previous program, it's gonna be hard because you gotta really get that one working to do this one. Right, class? So this program is dependent on you doing the array program from the previous assignment, right? Everybody got that? Okay. It says using the previous array program, right? Not vector, array program, all right? Sort and search, rewrite the program, and it's not a lot of you rewrite the program using a pointer to manipulate and display the original and sorted content. That's all you're doing. You're not changing anything dealing with your sort. You're not changing anything dealing with your search. You're not changing anything dealing with your reading of the information. Like I said, unless I gave you comments as to you need to, the data need to be initialized. I mean, names need to be initialized and whatever. So you need to change that so you can get all your points. But you shouldn't change anything other than your output function. Now, how should the output function be changed? All right. Using, in a sense, this is the array name, array plus plus. So whatever your array name is, like if you got a name, you're gonna output it using name plus plus, where that the name is the what was the array here? Let me say array. Using array plus plus, where array is the name of the array. So if I had an array called name, I had an array called year, and I had an array called amount, I would do my cout do my loop, and then in the loop for the index equal to whatever, less than whatever, cout, whatever array plus plus, what name plus plus, whatever plus plus, whatever plus plus. And that loop should allow you each time to manipulate and bounce to each address of those arrays to get to the next value. All right. Now we're going to look at how that work in the notes, because remember when we allocate space for arrays, what happens when we allocate space for arrays? Like say if we have a int array, what's the byte size of a single int of an int?
4.
4 bytes. Now, if we had an array of array of size 4, how many bytes is needed to allocate that array?
16.
16. Now, this is the other key. When an array is allocated, it is allocated contiguously. All right. The information is not bounced around addresses throughout your memory. It starts at one point, 4 bytes, then the next 4 bytes, then the next 4 bytes, and then the next 4 bytes. So it's contiguous, right? It continues, right? So now that's why you are able to use array plus plus. So array plus plus, when it's 0 or the name of the array, you at the beginning of the array or the first element. When you add to it, it bumps up how many bytes? If it's int?
4 bytes.
4 bytes. So now I done move to the beginning of the next address, which is the next what? Value. Then I do the array plus plus again, it bumps up to the next one, array plus plus, and it bumps up to the next one. If it was char, it would only bump up what? How many
byte.
bytes at a time? Huh?
1
byte.
1 byte at a time. So you understand what's happening here. That's how you can manipulate arrays by its address using the plus without using subscripts. All right. So it tells you, make sure that you upload the file in the associated format. So it's like I want my C++. All right. Hopefully in Visual Studio. They had a file, hopefully in Visual Studio. Doesn't have to be, but make sure it can run in Visual Studio. And the data file, all right? The file that you're reading in. Your output going to be to the screen. Now, that's just the program. You can get all your 25 points. An added 10-point bonus. It says for each of the sort and search functions, all right? So if you have a sort function, and your a search function. If you use a pointer, all right, which is the array address, as the starting point and the last element as the ending point, and if you manipulate the array, all right, not using subscripts, all right, to assign or compare elements, all right, then you can get 10 point, get 10 point bonus, right? Set each array to the pointer and pass the array as a function parameter, all right? And then output all of the current values using 2 decimals. Oh, that's just the 2 decimal places. But here, if you manipulate your sort and your search using pointers, you get 10 points. Now it's a challenge, but you can do it though, you know. But like I say, if I was you, I'll try to get the program running in this fashion first, and then save that copy. And like I say, or even upload it to the assignment, and then come back and start working on this part. And if you get it, then upload it to get your bonus, you know. And it's because I'll grade the last one submitted. All right. So that plus plus, remember that when we get back to our notes, all right? So let's look at the other program. Oh, I got this in the way. The other program is similar, all right? Very similar, all right? Basically what? You're doing the exact same, oh no, this is the cover page. And the documentation. All right. So this program is basically exactly the same thing, but now you manipulating your array using a different way. All right. So look, using the previous array program, not the vector program, the array program, sort and search. All right, which is the sort and search. Rewrite the program. All right, processing the array using pointer notation to manipulate and display the original and sorted content. All right. So really you should have more. Well, if you did it the way we talked about, you should have one output function. Once you change that output function, you're done. Some people, they'll try to do an output function, then another output function after it's sorted, which is should be looking exactly the same way, you know. But you should have that one output function. But look what it says. Using this particular notation, right? All right, where array in here is the name of the array and X is the subscript or the element of the array, all right? Not necessarily the subscript, the element, all right? But then again, same instructions, all right? About the header, the source and the data file, and then your bonus, okay? So just make sure you get this one right first and then come back and try to do the bonus part, okay? Questions?
Oh, Professor Sylvester.
Yes.
Okay, look, since you gave an extension to 3 and 4, and since these programs are based on that, I have a question about the data file.
Okay.
Like in the description of the program, the data file actually has titles at the top. Name.
No. Let's look at the data file.
Programs 3 and 4.
All right, let me show you. What I don't want to go to grades. What happens is
I had to use an extra array to bypass those titles so I could get to the data.
No, the title was, how would I say it? You know, if I give you a list of students, all right?
Yeah.
And some other information that goes with the students.
Yes, sir.
I'll give you a heading so you'll know what the data is. You understand?
Okay, so that's not part of the data file.
Correct. Now,
okay,
that can be, like say when you're working with a company, it can be, but you know what you do in that? Based on that, you look at the data file, see how many lines, if it's just that one line, you'll just do a dummy read. You understand?
Yeah, that's what I did. I did a array of strings of just 3, just to read the titles so that I could get to the actual data.
Right, but what you could have did, you could just did a read line, a get line.
Oh, right,
right. Just get the whole line and then fall in the loop to do whatever. Sometimes you have data files like that. You understand? But I didn't do that intentionally. What I did was in my assignments, I give you that so you would know. I think 3 and 4.
Yeah.
I give you that so you know what that data represents. You understand?
Yeah.
Because if I just list some data, you understand? See, now look, this is the original data, but this is the output format. You understand? That's not the data file. Wait, that's not.
Okay. Yeah.
All right. And see, but you're right, that's not the data file. That's just a sample of the output. You got me?
Yeah.
Right. So the data file normally would be just the data, but it can be headings. Give me an example.
So I can go back and change that since I have an extension now.
Right. Give me an example. When you export, like say I got I got your names or whatever in my my website to sign the road, right? If I export using SQL, MySQL, if I export that data into Excel gonna give like field 1, field 2, field 3, field 4 at the top, and then give me the data. Okay. Now, when I want to change that or read that into a program, I either need to delete that first row out or read that dummy row, you know, to eliminate it from being part of the data. All right. So you'll see that as you work with computers and exporting data and importing, you'll start seeing that, and you'll have to understand and know what to do and whatever to ignore that first column. And matter of fact, if I'm importing an Excel file into a MySQL, like a database, it'll ask the question, should we ignore the first line? Because normally that first line is just a description of what that data is. And sometimes you would say, yes, ignore it, because what? It's already deleted. And sometimes you would say, no, don't ignore it. You know, well, yes, ignore it because it's there with the description, or no, don't ignore it because it's the first record in the file that you've got. All right. So, like I said, you'll be able to see that. So, any other questions? Questions? All right. So now let's look at the notes. All right. All right, let's say we go to, not here, we go to 9. Now, these notes come from the book. It's just that I broke these out to whatever. You can look at these too, but you look at all the other notes for the test, because you know you need to look at all of the notes. All right. So make sure you also look at the notes from the text. So, all right. So we talked about how it allocates, because this is a char, this is a short int, and this is a float. All right. Could have been float, could have been int, which was what, 4 bytes. All right. We talked about a pointer program as where we can print out the address of a variable. All right. We can print out the size of, which is the size of bytes being allocated for that variable. And we could actually print out the value of that variable. All right. Then we also looked at how when we pass an array, when you pass an array, you actually pass in the address. When you pass that entire array, you passing the address. And then from that, when they pass numbers into values, it's passing the address. So whatever you do to values will be automatically done in numbers when you return back to that call function. All right. So that's what this is saying. It actually passing the address of numbers into values. All right. But see here, size, which was a constant, it's actually passing what? Just the value of 5 into size. But if we would have what? We would have passed it by reference and put an ampersand, and you know you have to modify your other lines of code in your program, then you would be passing the address of size into the address of this size, right? And these two sizes are different variables because what? In C++, Unix, etc., your variables are case sensitive, all right? The case sensitive, kind of like a password, case sensitive. And look, the same thing, passing by that reference. When we pass jelly donuts, all right? Jelly donuts is being introduced in the main function. Then we call in get order, but we passing jelly donuts into donuts, all right? But here we use the reference, by reference. So when we pass jelly donuts by reference, we are actually passing the address, so that whatever we do here to donuts, whether we read in a new value, multiply to equal to donuts, whatever, is changing the value at the address of jelly donuts. Okay, so that's what you got to understand with pointers. Okay, so, and this is just explaining the same thing. Jelly donut is being passed as an address into the donuts. All right, the address, and whatever's done here, you could give it, you could say donuts equal 50. It'll change jelly donuts to equal 50. Whatever you do to it and equal it and make it equal to, it'll do it at that point. All right. Now, we looked at this, and we also looked at how to create a pointer variable. To create a pointer variable, you have to give it a data type and a variable name. But what did we say about pointer variables? A pointer variable, scratch integer. A pointer variable can only hold the address of the data type of that variable, okay? Might sound kind of funny, but look, what happens here, if this is a pointer, all right, they declared this pointer, and it's a pointer because of this asterisk here. Int, this asterisk signifies that, hey, this is gonna be a pointer. This pointer variable can only hold the memory address of an integer variable. Nothing else. Everybody understand that? Can only hold the address of an integer variable. Now, who could tell me why would that be significant?
Well,
Why
you
would
would have to specify what kind of data you're setting to a pointer, right?
Okay.
So you could have like a double pointer or a character pointer.
And why can a double pointer only hold double values? I mean, addresses. And integer pointers can only hold integer addresses.
Because of the byte size?
Correct. Because if I create a double pointer and I input an integer address, it's gonna try to attempt to read what? 8 bytes, right? So all of a sudden now I'm going beyond the boundaries of what I'm trying to read. If I'm trying to read store an integer, but it's a float, it might try to store 8 bytes of something, well, 4 bytes of the integer and 4 bytes of something else. Everybody understand that? So you got to make sure that your pointer address can hold the data type that it was declared to hold, all right? Otherwise, you get errors. So we looked at this program where we set x to equal to 25, an integer. Then we created this integer pointer. Once we created this integer pointer called PTR, I can actually print, make the address of x equal to that pointer. I could make the address of y, if y was an integer, equal to that pointer. I could make the address of cost, if it was integer, equal to that pointer. Not all at the same time, but I can do it, as I choose. Everybody understand that? Everybody got that?
Yeah.
And then I could print the address of that location and the value. Because look here, if I just print out X, like we normally do, it's gonna print out the value 25. If I print out just PTR, the pointer variable is gonna print out what? The address. Because a pointer variable only holds a what? Can only hold a what? An address.
Memory address.
Correct. It can't hold a value, it holds an address. Okay, so that's the difference. Now, so that's all this is saying. X was allocated at this memory location, all right, which is this memory location. We don't see the memory location as programmers because it's a 5th generation language. When you're dealing with low-level languages like assembler, then that address could become very important. But like I say, all we know is when we want to use X, we're gonna use that value at that location of X. But if you wanted to write low-level coding, then you can start manipulating data by using that memory address. All right. So it just tells us that X, which is located at this memory address, contains the number 25. Now remember what I said also. If you run a program, let me go back here. If I gave each one of you all this program to run on your computer, you will still get X for 25, but we all may get a what? A different what? A different address. Because what? That memory address on my computer might be free, but on your computer, that address might not be free, so they're going to use maybe another another memory location to store that value in those 4 bytes. So even though it's a different address, it's still the program will still run. All right. It's just that it has to it randomly allocate that space, and it don't have to be the same memory location for the programs to run. All right. All right. PTR could be used to change the content of the variable using the indirect operator. All right, which is that asterisk. All right. Now, so remember we looked at this part of the program before we left class the last time. What happened? We had a variable called X. All right, it was integer. A pointer variable called PTR. We assign the address of X to PTR. We outputted X, but then look what happened here. They use the ampersand so that they can what? Indirectly reference it, using the address, right? So they use the ampersand in front of the PTR so that they can actually print the value at that memory location. Everybody see that? So once they printed X, they got 25. When they printed indirectly using the indirect reference, which is the asterisk, PTR, they printed the value, all right? And then look what happened. They said, okay, PTR was equal to X, right? Where's that? Well, PTR was equal to the memory address of X. Right here, we saying, all right, PTR, which is what? The value 25, because it got the asterisk, is equal to 100. So now what? You say, well, Mr. Sylvester, I thought you said the pointer variable is the memory address. It is. But when we use this asterisk here, we saying what? I don't want you to reference the memory address. Let's reference the value at that address. So now I'm working with the value. I could say PTR is equal to 100. Then now when I go here, I could print out X, and then I print out asterisk PTR, and it's going to print out the 100. Right? Everybody got that. But if I wouldn't have put the asterisk, it would have gave me the memory address. Everybody understand that? Now, the thing is too, what? If you look at this, X was changed from 25 to 100 without actually what? Assigning a value to X. Everybody see that? It assigned the value to what? The memory location, all right? Everybody understand that? Question?
So if you were to put a cout statement and just reference X under that pointer value with the asterisk, would it print 100 then?
If I did what? Cout X?
Yeah, but in the underneath all of the
right here,
couts underneath that.
Right, like right here. Look, cout X.
Yeah.
And it gave what? 100. Because at this point, we did what? We were pointing at X, right? And we said we want to use that indirect operator to reference the value. So now we taking the 100 and storing it and replacing the value of 25 at the memory address of X with 100. So anytime now when we reference X, it's what? 100. And the PTR indirect reference is 100.
Okay.
Right?
Yeah,
okay.
Right, yeah.
Right. So that's what happens. Now, so and it give us this explanation here. This statement references the value PTR is pointing to. When you use the asterisk, it actually references the value at that memory location. All right. If I just see out PTR, it's going to output the memory, right? The memory address. All right. This would output just the memory address. All right. Now, then if I do this, now this gives me the opportunity to say what? I don't want to actually deal with the address, but at that address, I want to deal with the contents, and I want the contents to equal to 100, wherever I'm pointing to, all right? So given that the indirection operator is used in PTR, 100 is assigned to the item PTR points to whatever that value stored in that location, which changes whatever variable we're pointing to. If we are pointing to X at the time, it'll change the value at X, the address of X, all right? Because remember, this is an integer pointer. Wherever we pointing to, that's the variable it's going to change the value for. Everybody get that? Everybody understand? I could have 5 different integer values and 1 pointer. Depending on which variable my pointer is, the address that my pointer is referencing, that's the memory location that's going to be changed. Okay, so that would make computers programming kind of tough at times. If you're dealing with pointers, you got to make sure you pointing to the proper location to make the change. All right. So look at this program. This program deals with 3 integer values and 1 pointer variable. Okay. You got int x, y, and z. Okay, X is equal to 25, Y is equal to 50, and Z is equal to 75. Now, so it tells you output X, Y, and Z. Oh, so it outputted X, Y, and Z, which was what? 25, 50, and 75. But check this out. What they did was they changed the value at those memory locations without actually, how would I say it? Assigning the value to that variable itself. It used the pointer. But if you look here, look at this statement. PTR, remember PTR, this is the variable, integer variable. PTR, well, and it got the indirection operator. It says PTR, so now we relating to the value plus equal 100. So whatever is equal to, we adding 100 to it. But let me ask you this question. What address or what variable is changing at this time? X, Y, or Z?
X is.
X. Why X? Because it's pointing to X, right? When we did this, right, it made the address of the pointer equal to what? The address of X. Look up here. All of a sudden, we say what? PTR is equal to what? Ampersand Z. What we did here?
Switch the pointer to point to Z.
We switched the address. Now we referencing what? Z, right? So now when we do asterisk, when we do the indirection, PTR plus equal 100, what are we doing? We adding 100 to the what?
The address of, or the value of Z, I'm sorry.
Correct. So you understand how pointers, you can change pointers to reference those different variables, right? And look here, this last one, well, let's see, or did I miss one?
No, I don't think Y is.
Oh, yeah, I did, up here.
Okay.
Yeah, so look up here, PTR ampersand Y, right? So what we did at this point? We made PTR equal to the address of what? Of Y. So now when we use PTR and we use the indirection operator, we adding 100 to what?
Y.
To Y. And then when the output, and when we go back and output X, Y, and Z, the exact same statement we have up here, notice, 25 became 125, 50 became 150, 75 became 175. So see how we changed the value at those memory locations without actually using the variable in that assignment statement. But we use what? The indirection of that pointer, operator for that pointer. Everybody see that? Questions? Questions? All right. So, and this just explains what happens or how those statements work. If, let's go back here. Let me ask you this question. If I were to remove, well, let's say this is the program, and we follow through. If I were to remove this statement and this statement out of my program, what would my output be for this second line?
325.
What will my output? You're on the right track. What will my output be for X, Y, and Z?
I'm sorry, it'd be 325, 50, 75.
Correct. There you go. There you go. Because what? I'm printing X, Y, and Z. What happens is I'm setting the pointer to X, and then I'm adding 100 to that memory, the value at that memory location. But if I don't point to Y and I do this again, where am I pointing? Where's my pointer pointing? If I don't do this, it's still pointing at X. So when I do this, it's gonna add another 100 to X. So, and if I don't have this point where it points to Z, it's gonna still be pointing where? At X, right? And it's gonna add another 100 to X. And when I output, it's gonna output 325, 50, and 75. Everybody see that? So that pointer is very, it's very important to know that you have to point to that variable before you can manipulate it, all right? And like I said, when you're writing with pointers, that's one of the main issues, not knowing where you're actually pointing to. And you're not pointing to something, or you're pointing to something else, and you're changing things, and you're not looking at it as a variable X, Y, and Z, and you're like, man, what's happening? Why is this happening? Why? And then if you try to track it, then that's when you see, oh, I'm pointing to the wrong variable. And then it's like you get your program done. All right. So this just explains what happens. It pointed to X, it added 100. It pointed to Y, it added 100. It pointed to Z, it added 100. So that's all that happens. All right. So, and like it's showing you here, you got three different three different uses for the asterisk. All right. You can multiply something. You can use it to define a pointer, and you can use it as the indirection operator. So there's those different ways the pointers the asterisk can be used when you're writing code. So you got to be very, very wise when you're doing it. All right. So now we're getting into the meat of our programming, because remember, this is one of the formats you're going to be using to do what? Modify your code, right, class? So we looked at all the other stuff to get you to kind of understand what's going on. Now we're going to look at how we can use this particular feature to manipulate your loops for your program. So we got this one, and then we have this particular one, the plus plus. Let's see what a plus plus at. It should be here, but we're gonna get to it because that's the one that's pointing to it. But we'll get to it. So let's look at, and it's right. It should be red. Nope, it's not done. All right, so let's look at the first one. So it says arrays and pointer relationships, all right? And look at this program. In this program, you can have a short array, all right, numbers. So that's what? 2 bytes, right? 2 bytes at a time. So numbers is the array. When I see out ampersand, asterisk number, I'm doing the indirection, and I'm printing out number, all right? Numbers. This, when I reference the name of the array, I am at the beginning of the array, the starting address of the array, right? So if I'm doing this is gonna print the first value. So as we learned in chapter 7, an array name without the brackets, all right, and the subscripts actually represents the starting address of the array, okay? Therefore, an array name is actually a pointer. So here, what's the pointer? The starting address. Here, what we outputting? We outputting the first value. So this is done by using the array name preceded by the indirection operator. So now, so this will output, because it's not in a loop or anything, right? And it's never been moved. It's just gonna print what? The first element of the array. Everybody get that? Everybody understand why? The name of the array is the first, is the beginning address of the array. The indirection operator tells us we want to reference that address, but then we want the value. So that's going to give us the first element of the array. Okay, the value of the first element of that array. Simple little program. So because numbers in the above code works like a pointer, all right, to the starting address of the array, the first element is retrieved when numbers is dereferenced, all right? Remember array elements, array elements, that should be elements, are stored together in memory, all right? In what? Contiguous form, right? One after the next. All right, so let's look at this. It is important to know that pointers do not work like regular variables. When used in mathematical state, when you use them in a mathematical statement. In C++, when you add a value to a pointer, you are actually adding a value to the size, right? So if I do the array name plus 0, it's the what? The first position, right? Array name plus 1 says, okay, 1 times the byte size, all right? So if it's an int, 1 times 4, it done moved it to the second position, all right? Array name times 2, if it's an int, byte size 4, 2 times 4 is 8. So it went to 4 for the second one, then 8 for the next, which is the third byte. So that's how it actually works. So let's look at this. So it says, you're actually adding the value times the size of the data type being referenced by the pointer. Therefore, if you add one number, all right, well, add 1 to numbers, you actually are adding 1 time the size of shorts, which is the data type to numbers, right? If you add 2 to numbers, the result is numbers plus 2 times the size of, all right? So, and so forth. So if we use this, and this is what I told you you're going to use in your program. So once you fall in your loop, you got your arrays for your name, year, and tuition. You fall in your loop. This could be a what? This here, 1, 2, 3 can be what? Can be a loop counter, right? If you're starting at 0, using this indirect operator, then numbers plus 0 is the what? The very first position. So when X is 0, I'm printing out the first value. I could see out that. I could see out the asterisk numbers plus 0. Then when numbers is 1, I could print out the next value. When it's 2, the next one. When it's 3, the next one. So everybody understand that. But it's telling you, this just giving you an example of what it actually does. Numbers was of short, yeah. So that's why what they did was you're actually multiplying 1 times 2 added to numbers, which is the address. So you're bumping up 2, all right? And if it's 2, 2 times 2 is 4, so you're bumping up 4 from the beginning of the address. Everybody understand that? All right, this automatic conversion means that an element in an array can be retrieved by using its subscript or by adding its subscript to a pointer, right, to the array. If the expression asterisk numbers is the 0 position, all right, which means numbers asterisk, and then the parentheses, numbers plus 0. If it retrieves the first element in the array, this should be then. I think. The asterisk numbers plus 1 retrieves the second, and so on and so on and so on. So everybody understand what's going on here. Everybody understand what you're gonna be doing in your output loop. You're gonna be changing it from using subscripts to using this format here. And like I say, this just showing you the dinosaur way. But what? If I use X, I could have put this in a loop for X equals 0, X less than whatever, X plus plus, and then I could say C out asterisk numbers plus X. When X is 0, I'm at the 0 position. When numbers plus 1 is at the really first position. Plus 1 is at the second position. Plus 2 is at the third, and so on and so forth. All right. So this just showing you a picture diagram of what an array would or could look like. A short array of 4, 2 bytes, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. All right. Memory address, asterisk numbers. That's the beginning address. The first address, num1. I mean, not the first one. The next element, asterisk numbers plus 1. Now, notice how you have this here. You could also do what? Parentheses plus 0, close, right? Close parentheses. Because, like I said, you couldn't put 0 here. That'll be the same as doing this right here. Same difference, all right? Same difference. All right. So that's why I say you could put in a loop, because you don't want to just reference it like this and then try to do these different, all right? All right, so the parentheses are critical when adding values to pointers, all right? The asterisk, which is the indirection operator, the asterisk operator has precedence over the plus operator. So the expression asterisk numbers plus 1 is not equivalent to what? The asterisk numbers plus 1 here. Because what? Who could tell me the difference between this address, this expression and this expression?
I believe the first one would be adding 1 to the value of numbers.
Bam, correct. The first one says, okay, go to that memory location, all right? Do the indirect operator, give me that value, add 1 to it, right? And then the second one does what? What does
It uses numbers as it's the, I can't remember the name of it.
It moves it to the next.
It moves it to the next
address,
array
yeah.
location.
Right, the next address, right. So wherever we are, if we add address number 3, and we add 1 to 3, right? It'll go to 4. If we add number sub 0, then it'll what? It'll move it to the next to the first to the next second element, right? So that's the difference in the two. This one will add 1 to the location of that memory of that value at that memory location, and this one will actually bump you up 1 from wherever you are in that array. All right. So when working with arrays, remember the following. All right. Array sub index, right, which you already have in your program. You got names of whatever, years of whatever, and costs of whatever, right? Using subscripts is equivalent to this. So really, I'm giving you the answer, right? Because you don't need to change nothing with your loop. All you need to do is modify your your output, right? Because this is equivalent to this, all right? C++ does not do bound checking. And in a sense, it doesn't, because it's a low-level language, but it will give you errors at times saying subscript is out of bound when you're violating and going into another variable. So when stepping through an array with pointers, it is possible to give the pointer an address outside of the array. Because what happened is, if you're referencing a short, and then what happens, you add, like I say, your array size is only 10, but you done added 32 to it, it's gonna move to that address location, and it could be an integer value at that address, and it'll pull it and you'll use it, but you may have the wrong data. So you gotta watch when you're using pointers, all right? So looking at this, again, what we was talking about when I forgot who answered about those two different methods. Look at this small program. They created an array of shorts called numbers, all right? They initialized it to equal to 10, 20, 30, 40, 50. They put it in a loop, all right, to output the values. So what happened? They outputted X, the first location for X equals 0, X less than 5, X plus plus. So when X is 0, and we did this here, we multiplied num plus X collectively, which means not really multiply, using that indirection operator. It says, okay, X is 0. So 0 times the byte size, which is 2, 2 times 0 is 0. So we are at the what? The first memory location, which is the beginning of the array, which is 10. Now, look at the next one. This one says ampersand, ampersand, asterisk numbers plus X. So what this says here is, okay, we want to take the value at numbers and add X to it. 10 plus 0 is what? 10. So it printed 10. Then it incremented X for the loop. And then what? X become 1. It printed 1, but then what? Numbers plus 1 times 2, that give you 4. So that's 2 here, then 4. No, 1 times 2. 1 times 2 is 2. So you get 2. So this is the 0 part. So you move up 2 bytes, and now you at this address where 20 is located, and it's gonna print the 20. But this here, we're at X is 2, X is 1, right, excuse me. So we're doing numbers starting at 0, because what? Asterisk numbers is the what? First location, which is here, right? It always is the beginning address, correct? Then we add 1 to 10 and we get 11. So see how that works? And then it continues on. So this here will always add 1 to that memory location, all right? So that's all that's happening here. But then this one actually referencing each individual memory allocated space for your array. Questions? Anybody with questions? All right, so here we go. Look at this. So here we have a short, but then look what they did here. Now they did what? Basically somewhat the same program, all right? But then they said what? For X equals 0, X less than 5. Now what is this? This, if we go back up here, is a pointer, right? PTR num is a pointer. But now what happens? PTR num is equal to the memory location of num sub X, right? Everybody understand that? So this becomes the address of the first position when X is 0, but then what? For that pointer, we're doing the indirect operation, so we want to get the value at that memory location we pointing at. So it's going to give us the 10. So we go back up, right? And then what happened, X becomes 1. So now this changed to the memory address of number sub 1. And that address is being passed to that pointer. Now what? we're using the indirection operator to print out the value at that next position in our array. So it's gonna print out the 20. So see, there's different ways you can manipulate your pointers or get the values from using pointers. All right. Anybody with any questions about that? Questions? All right. And like I said, you could go through these, look at these, whatever. Now, remember what we said about, well, let's say we talked about that pointer variables can only hold value addresses and can only hold addresses of the same data type. All right. So look at this. The only difference between array names and pointer variables is that you cannot change the address of an array name, well, the address an array name points to. Once I allocate an array in my program and it has a starting point, it's there for the entirety of the program. You can't change it because what? If you can do that, then you change in all of the other allocated space for it, and then you wouldn't be able to track it using what? Pointers, by it moving so many bytes based on the byte size. All right. So given this, you have double. So this is a double. So this is what? 8 bytes. I got readings, all right, array of 20. Totals, array of 20. And then I got double, all right, and then I'm creating a pointer called DPRT, all right, DPRT. So now what happens? I can do readings DPTRT because what? This DPRT is a double pointer that can hold what? Address of a double variable. All right. This is legal, valid or legal because total is also double, and this pointer can accept a double. All right. But look here, you never can do this. I can never say readings is equal to totals because what? Readings has a memory, allocated memory and a starting point. Totals has allocated memory and a starting point. Just the name of reading is the beginning address of reading. All right, totals is the beginning address of totals. So that's a conflict. I'm trying to take one array and assign it to the same, the same memory location. I can't do that. All right, so that is illegal. The starting point, that's illegal. Now, DPTR equal total. Remember, total is an array, right? And then the total by itself is an address. DPTR is an address or may have an address, but I cannot overwrite total's address because once I allocate it here, DPTR, here, double totals, I done allocated my 20 spaces. I have my starting point. So if I try to overwrite my starting point, that's a violation. Okay, so you cannot do that. So any array name is a pointer constant. Okay, and that's basically what they're saying here. I cannot overwrite this constant value. I cannot overwrite this constant value. And no matter what, I could be trying to give it the same address. Cannot do it. Okay, this can't be done. All right, so here we go. This is a part of the first program. Remember what we did with the asterisk parentheses, the array plus index was the second program. This is a part of the first program. Now it's in a sample program, so you got a little example as to how to do it. All right, but look what they did here. All right, what they did was, they use a pointer. They use a pointer called short. We still using our short array. Class is over. But let me finish this so you can kind of understand what you're doing with your assignment. All right. So what they did was they created a pointer. So now they assign that pointer to the starting address of numbers, okay? And then they fell into this loop, and then they said, see out what? And they dereference what? Or use the indirection operator, and they outputted what? The value at that starting point. But then look what they did. They didn't do the asterisk time or whatever, num time, whatever. They just said, okay, that pointer, I want to add 1 to that pointer. But really, if that pointer is of short, when I add 1 to it, I'm really adding what? 2 bytes. Remember? That pointer is of double. So it can, every time you add to it, it moves up 2 bytes. Just like if it was int, every time I add to it, it'll move up 4 bytes. So that's what's happening here. So it'll move up each time and output each individual value. But look what happens here. Just like you use the plus plus, you can use the minus minus. So what happens, now notice what they did. They did the plus plus because what? They started at 0, they added, and then they added to, and they had to check, oh, it's out. So before they started outputting again, they had to do a subtraction before because they'd have been what? Out of the boundaries of the array. So they did a minus to come back 1, and now they can start from the end, going from 50, 40, 30, 20, and 10. Because you start, because the pointer is pointing to the end. See, when I did the plus plus, I added the last address to my pointer, right? So, and then here I did the minus minus. Well, when I did the very last plus plus, it went out the boundary. Then I had to do the minus minus to come back into the boundary to be at the very last one. And then as I go through the loop, I do the last one, and then I do all of them until I get to greater than 5. I mean, X greater than 5, and then it stops. All right. So that's how, and then like I said, this just kept doing the minus. That's how you can manipulate your arrays. All right. So class, you can go over this, look at this, some of these notes, look at your other notes for your tests or whatever. But that's pointers. And like I said, there's a whole lot you can do with pointers, but all I want you to do is learn how to manipulate your arrays using the pointers, all right?
I actually have a question really quick.
Gotcha, what you got?
So when you're using a pointer, do you have to define it as a global variable to be able to
No,
use it like that?
No, you don't, but it's just like a regular variable. If you define it within the main, then you can only use it in the main, right? If you look, and then if you look further in the notes, when we go here, it showed how you can pass that pointer. See here? Like if I declare the function, in my main, I can actually pass a pointer just like I pass a vector, just like I pass whatever. You got me?
Yeah, I see that.
Right, and then what? Use the ampersand, whatever, because you're referencing that address. You understand?
Yes, sir.
Right. And then here in this, you're looking at this would be the pointer variable. You got me?
Yeah.
Val. And what's happening is, if you see this asterisk here, this asterisk says, okay, don't use the address, use the value at that address. This asterisk says, whatever that value is, multiply it times 2, and then store it in that value. And then what happens, whatever's done here is done where? At that pointer number. So whatever's done at val, gonna automatically be done at number. So when I print out number in my call function, it's gonna give me that value.
Right, okay.
Right, okay. Yep. All right, and like I say, this is a sample, I think, sample. This is the sample program. So you could type that in and look at it and go through it and see what's what, and then see how it works and whatnot. Yeah. All right. Any other questions?
Yeah, Professor Sylvester,
Yes, sir.
I was waiting till the end of class because,
Okay.
listen, as you know, my situation, I won't be able to attend the Linux class physically. So can I use this Zoom link tomorrow?
No, look, hey, the Linux class is totally online. All right.
Oh, awesome. Okay.
Yeah, they changed it. Now, with that Linux class, I gave you a test out link in the syllabus, I think, and you need to register with test out. And it's I think there's a code you need to buy or buy. And like remember I told you simulate some stuff simulated.
Right,
and you go through those simulations. I'm also at time post, like remember you was trying to do that virtual box.
Yeah.
Yeah, I'm a post assignments, randomly, not many, but I'm gonna post some of them. But the majority of what y'all doing gonna be through that test out. And like I say, you work through that test out. It's like a training, whatever. And at the end of the semester, you if you take that take the certification and you pass it, you will get that certification. They'll mail you or give you a printout online of that Linux Pro certification.
Okay, awesome. Awesome. Right. So is there a way, okay, since it's all online, I'll be able to test out at the end of the semester,
right? Yeah, because I control everything. Right.
Okay.
I'm gonna set up the test during the final exam where you could take the test. Right. Yeah.
So to be clear, we don't meet in class?
No, but what I'm gonna do is maybe 2 weeks into the semester, I'm gonna send out an email to have a Zoom session so that people can ask me questions. Because sometimes online you have stuff out there and it's like, I don't know where to go, what's what, how, whatever. So they'll get a chance to ask me questions back and forth and be at ease as to what it is they need to do. You know what I'm saying?
All right, awesome.
Yeah.
Awesome. All right, thank you, Professor.
All right, no problem.
All right.
All right, anybody else? Question? If there's no questions, like I say, continue to work on it. I extended those days on the other assignments, but this 5 and 6 is predicated on you completing the other 2 assignments. All right, so make sure you get them done. All right.
Thank you, Professor.
All right, you're welcome. All right. Man, this thing here. I need to post this.